Okay, let's look at 10.2, which is fractional exponents. And so the two rules we're going to look at today, the first one is that x to the m over n is equal to m to the root of x to the n, or the mth root of x over n. So I know these formulas sometimes seem a little confusing, but I always tell everybody to think of the top number is your power and the bottom number is your root. So when you have a fractional exponent, the first number is the power and the bottom number is the root. And you see that this is x to the nth power all to the m root. So top is power, bottom is root. So when we look at 81 to the 1/2, this top number is your power and this bottom number is your root. So we're going to use this to switch it up, or this is your n and this is your m. So it's going to be the second root of 81 to the first power. Or do you see that a fraction of 1/2 is just another way of writing a square root? This is really just saying the square root of 81, which is equal to 9. So when you have an exponent of 1/2, it's just another way of writing a square root. So this one, 8 to the 1/3, again, the top number is your power, the bottom number is your root, or if you're using the formula, n over m. So this is really just the cube root of 8 to the first power. But anything to the first power is just that number. So this is really just saying the cube root of 8, which is equal to 2. Let me pull, I just did this lesson, so I'll slide this under, but here's our square roots and cube roots over here to the side if you want to move this down. Want to look at those. So we talked about this in the last lesson, that the cube root of 8 is 2. So what I really want you to realize is that a 1/2 is a square root and a 1/3 is a cube root, so that you really don't even have to use this little formula. So the 25 over 36 to the 1/2 is just the square root of 25 over 36, or 5/6, because the square root of 25 is 5 and the square root of 36 is 6. Or anything to the 1/3 is the cube root, so this is the cube root of -8. And remember, we learned last time that odd roots can have a negative, so the cube root of -8 is -2, because -2 times -2 times -2 is -8. This next one, 1/2, is really just a square root, so this is the square root of -25. But remember from last lesson, we can't take the square root of a negative number, so the answer for this one is not real. Okay, so when it's a 1/2, it's a square root, and when the exponent's a 1/3, it's a cube root. But now let's look at some that have a number in the front. So we've got 25 to the 3/2. So remember, the top number is your power, the bottom number is your root, or you can think n over m, whichever you'd rather. So this is the square root of 25, so the 2 goes here, to the 3rd power. So you can do this in any order. You could do 25 to the 3rd, but you're going to get a really big number, and then you're going to have to take the square root of it to go back. So I always say do the root first and then do the power, because we know the square root of 25 is 5. So that leaves us 5 to the 3rd. And then 5 to the 3rd is 5 times 5 times 5, which is 125. Wrote too far over there. So 25 to the 3/2 is equal to 125. Now let's look at these two. They're the same problem, just one has parentheses and one doesn't. So one of the biggest mistakes people make is when you have a negative out here, they use it for this exponent. But when you have an exponent, it only goes to the number right beside it. It only uses that negative if it's in parentheses. So this one, the whole thing would go inside. This one, it would not. The negative stays outside. And then we do the power over root. So this is your n and this is your m. So this would be the second root of 16 to the 3rd power. The negative stays out front. So this would be the negative. So we're going to do just the square root first. We're going to do this right here. The square root of 16 is 4. So -4 to the 3rd. And again, still the negative is not included in the exponent. You just do 4 to the third. So you'd say 4 times 4 is 16. 16 times 4 is 64. So your answer is negative 64. But this one you see is in parentheses. So it's because it's in parentheses, then all of that's going to go underneath. So the negative stayed out front, but this one's going to be the square root of 16, negative 16 to the third power. But now when you go to do a square root, can you do a square root of a negative? No. So this answer is just not real. We can't take the square root of a negative, so we just leave it like that. Okay, and then this next one is this last rule that says that if you have x to the negative n over m, your answer is 1 over x to nth root of x to the n. So think of this negative as meaning you're going to flip it, and your answer is always going to be a fraction. A negative exponent is another way of writing a fraction. So when I'm looking at this 36 to the 1/2, this negative means to flip it and make it a fraction. And then this is your n and this is your m, or your power over root. Because on a test, well, this class you'll be taking it home, but when you're in your college algebra class, you may not have this memorized. So if you think of power over root, that will help you too. So as soon as you see this negative, your answer is going to be 1 over. It moves the root to the bottom. So you start with 1 over, and now the negative is used up, and this would just be the square root of 36 or 1/6. So a negative exponent is always going to have a fractional answer. That's what the negative is doing, is it's another way to write a fraction. If you remember back from 0300, we looked at like x to the negative third was 1 over x to the positive 3. That negative flipped to the other side and became positive, so it makes it a fraction. So let's look at this one, 27 to the negative 1/3. Again, that negative makes it a fraction. So as soon as you see the negative, write 1 over, and then it's the third root of 27. So we look at our cube roots down here. The cube root of 27 is 3. So your answer is 1 over 3. 81 to the negative 1/2. If you want to start getting faster at it, just think the negative makes it a 1 over, and the 2 makes it a square root of, the 1/2 makes it a square root of 81. So the negative flips it, and the 1/2 means it's a second root or a square root. So 1 over the square root of 81 is just 1 over 9. This next one has every single thing in it, so it's got a negative, so that's our fraction. And we've got a power and a root. So this is our power and this is our root. So I'm going to start with saying that's 1 over the fourth root of 16 to the third power. So we're using both of the transforms there. The negative does the 1 over, and then the n over m. Remember, the m goes on the outside and the n goes on the inside. And again, you want to do the root first just because it makes it easier. So the 1 is going to stay there. And then the fourth root of 16, if you don't know what that is, you just kind of guess. I'm just assuming it's 2, but let's check. If you do 4 2s, 2 times 2 is 4, times 2 is 8, times 2 is 16. So the fourth root of 16 is 2, but don't forget we still have our to the third. So our final answer is going to be 1 over 2 times 2 is 4, times 2 is 8. So do the root and then do the power. Okay, these next two, they're both already fractions. So when you have a negative and it's already a fraction, think about, I just kind of think flip, because if it's not a fraction and you flip it, it makes it 1 over it. You're flipping it to the bottom. If it's already a fraction, you flip the whole fraction. So this negative is going to flip it and make it 36 over 25. And then 1/2, remember 1/2 is just a square root. So the square root of 36 is 6, and the square root of 25 is 5. So the negative flipped it, and the 1/2 meant square root. Remember we talked about that up here, that a 1/2 is a square root and a 1/3 is a cube root. So then let's look at this last one. Again, the negative flips it, and this is power over root. So first we're going to flip it and make it 27 over 8, and then it's the cube root all to the second power, which seems like a lot, but okay, so again, let's cube root it first. So the cube root of 27, we're going to look at we've already done this in the last lesson. The cube root of 27 is 3, so this becomes a 3 squared. And the cube root of 8 is 2, so that becomes a 2 squared. And then 3 squared is 9, 2 squared is 4. So that's our answer. Let me square all the answers here. Okay. So then one last thing, and this is reviewing the rules we learned back in 0300. I should have written them at the top there, and I didn't, but I'll write them over here to the side. So thinking back to 0300, we learned that when you multiply, I'll write it down here, that when you multiply exponents, you really add them. So an example would be like x to the second times x to the third is x to the fifth. You add those exponents. And that when you divide exponents, you subtract them. So that would be like x to the fifth over x to the second would be x to the third because you subtract them. So what makes these exponent rules nice is that you can go back and forth between a fraction or between an exponent. So if it's easier to solve it by fractions, you can do it that way. Or if it's easier to solve it by exponents, you can do it by exponents. Because if you look at this first one, this is 2 to the 1/2 times 2 to the 5/2. Because the bases are the same, when we multiply exponents, we really add them. So you can just leave the base the same and say 1/2 plus 5/2 is 6/2, which equals 2 to the third, because 6 divided by 2 is 3. And then 2 to the third is 2 times 2 is 4, times 2 is 8. And so you can use the multiplication and division exponent rules to help you even with exponential fractions. This one, the bases are the same. So when you divide exponents, you really subtract them. So the 27 stays like it is. But now we're going to say 5/3 minus 3/3 is 2/3. Now we have to use the formulas that we learned today up here, that the top number is your power and the bottom number is your root. So this transforms to be the cube root of 27 to the second power. Whoops, let me bring my cheat sheet back in here. We learned from last time that the cube root of 27 is a regular 3. So when you do the cube root of 27, you get a 3, but we still have that squared, and then 3 squared is 9. So we're using all these exponent rules to help us figure out the answers here. And then this last one, I wrote that really far apart, but it's really just x to the 8/3 times x to the negative 5/3. We're multiplying, so we want to add those. So 8/3 plus a negative 5/3, it's really like 8 minus 5 is 3/3, which equals just x to the 1. So those are your exponent rules that you'll use when you get up to college algebra to solve different things. So just remember, it's power over root, and when you have a negative, it flips it and makes it a fraction. So you're now ready to do the 10.2 practice problems.